Hello and welcome to the Build Better Homes podcast. I'm your host, Royal Mortier, and John O'Shea is not joining me today. So this kind of gives me an opportunity to do what I'm going to refer to as a new segment called Technical Topics. So with the technical topics, we're really just going to focus on engineering related items, how they pertain to residential construction, whether this be key changes in materials, products, hardware, building codes, design capabilities, anything that under that engineering realm that we look at every single day when we're designing everything for a new home. And this particular one is something that you're going to find in every home, pretty much every home in new construction. And it's one of those things we love and we hate, and that deals with the hardware that we're using. And I come from a long line of people in residential construction. I actually have a book, a master carpentry book from the early 1900s. And something that didn't exist back then was the hardware that we see commonly used in homes today. And the hardware that we use doesn't necessarily mean the homes are built cheaper or anything like that. They're meant to act as a element to really restrain the loading that we're looking at, whether that's wind, seismic, live loading, or uses of the property. It is meant to kind of simplify the construction. But one of the things I remember always walking around job sites with my grandfather and him talking about, why would I put a piece of hardware when in a situation when I know a nail would work, or maybe two nails would work? And we've come into this situation with engineers a lot where it's just a lot of specified hardware versus looking at the actual real construction of it. But there is some hardware that really helps us. And one of those pieces of hardware is a hold down. And what we use hold downs for is in a shear wall assembly. So that's our sheathing that goes onto an exterior wall. When we get into a situation where we have a lot more window openings and less shear wall material, we get into a situation where that wind load, or how that shear wall acts, right? It's resisting the wind loading, it's resisting the seismic loading. And as, say, the wind is pushing on the west wall of the house, okay? Well, now that means that the north and the south walls of the house are perpendicular to those forces, and they're resisting those forces. And they resist those forces through a few different ways, but the main key way is shear walls. Well, let's say I have barely any window openings in that whole length of wall, and that wall is 40 feet long. Well, that whole shear wall is resisting it. And if we think back to our use of lever arms, right, the longer the lever arm is, the less force I need. So if I've got a 40-foot long shear wall, my lever arm, or my forces resisting that pushing load, is much less. Now, let's say I take that same 40-foot wall and I put a bunch of windows and doors and accessories in it. Now I only have maybe an 8-foot section of wall. Okay? So now I've basically reduced my lever arm by a factor of 5. That means that my resistance that is pushing against it and actually giving us what we call a tension compression couple, or pulling tension into the foundation, has to be increased by 5-fold to give us the same level of resistance. So these hold downs are installed at the ends of sections of shear wall to provide us that tension compression couple to transfer those uplift forces, refer to them as, or tension forces, that pulling, resist that into the foundation. Now, for the longest time, and builders will understand this terminology, there's been a long-standing company that has developed a ton of hardware. They have a lot of booklets. They've really created a lot of innovation in the construction industry, and that's Simpson. Well, for the longest time, and as long as I've been in construction, the most commonly used hold down was called an HDU. Don't ask me what that abbreviation stands for. HD, I'm going to go with, stands for hold down. U, I think, refers to the shape of it, okay? But it's been a very commonly used tension style hold down in our industry. And now they're phasing out the HDU to phase in a new hold down called an HDU-E, okay? Some key differences with this is the HDU-E, with its certain types of installation, we actually get a pretty decent higher capacity from the hold down. Okay. Right off the get-go, looking at them, the big key differences are the standard HDU, and I'll kind of describe what it looks like. The base of the HDU has kind of a U shape to it. And the reason for that is, again, we have an anchor bolt coming out of the foundation that attaches to the base of the hold down. If we had a square base to that hold down, right, we're creating a rigid transfer, right? We're creating corner points, and corner points are rigid. Rigidity in engineering, rigid elements attract load. So when you have a significant bend, it tries to collect the load into it. So what you're going to get is you're going to get deformation, or you're going to get the load collecting until it deforms or until it deflects. By them doing a U shape at the bottom, it basically acts as a more uniform distribution of the load, the tension load, into that U-shaped base, so we don't get that bending of those corners or that rigidity in there. So the base of it is kind of a U shape, and then it's meant to be flat on the back to attach to your studs. And so you got your anchor bolt through the bottom, you have the flat back that attaches to your studs or your column, and then you have holes in the bottom for your anchor bolt, and then in the side of it for attaching to the stud, which is done through structural screws. Okay, so right off the get-go, the HDU, all of the screws are installed in the horizontal orientation. Okay, this is the old style hold down that's being phased out. They're all installed horizontal. So every single one of those screws is put in what we call a direct single shear. Okay, so going from the HDU to the HDU-E, we now have a mix. We have some screws are installed in a direct horizontal, so a single shear, and some of them are actually installed at about a 45-degree angle upwards. So we're getting a shear of the screw at a slight angle. And if we look at geometry and we take a sphere, if we tilt a sphere at an angle, we no longer have a sphere. If we were to cut a straight line through that at an angle, we no longer have a sphere, we have an ellipse. So we have more area of the screw being put in that direct single shear. We also now have a withdrawal or a tension capacity of the screw itself as that tension is occurring. So as a result, just the connectors into the wall, we're getting, by them changing that configuration, we're getting more area out of the screws, and then we're also getting a tension capacity out of the screws. Okay. In addition to that, I believe they've changed the configuration of some elements of the hold down itself. These are probably very minor. In college, I took a class on cold form steel, and it was really, really intriguing how minor changes in bends to the cold form steel resulted in significant increases in the capacity of the steel. So I think we're seeing how they have made minor adjustments in the actual configuration of the HDU-E to kind of draw out some more capacity out of it. Because what's interesting, and I'm going to give you guys a side-by-side comparison, and any framers out there or any concrete guys are going to know these callouts as I refer to them. Okay, so an HDU-2, and I'm going to refer to this for Doug fir. Okay, Doug fir is the most common material we work with. Spruce pine fir or hemp fir has a slightly lower design capacity, but Doug fir and spruce pine, for framing purposes and for Simpson hardware, they categorize those under one category, and then spruce pine fir and hemp fir, they categorize it as another because they have a lower capacity as the material. So for capacities, for a Doug fir or spruce pine wall framing construction, an HDU-2 into a double 2x member, you're going to get a tension capacity of about 3,000 pounds. The HDU-2 is also 14 gauge construction. The equivalent under the new HDU-E is also 14 gauge construction, uses one more structural screw, and also affixes to a double 2x. And we go from right at 3,000 pounds to about 3,800 pounds of tensile capacity, using the exact same concrete anchor. So we're getting a little more strength out of it. Now we go up to the HDU-4, again, 14 gauge construction, and its replacement, the HDU-E5, also 14 gauge construction. They both use the same number of structural screws. They both affix to a double 2x, but strength capacity, we go from about 4,500 pounds to about 5,400 pounds. So we're getting almost 1,000-pound increase. So about a 20% increase in overall capacity. When you look at it as the percentage of increase, that's a pretty significant change considering same gauge of material, same number of screws, same affixing element, and also the same size anchor bolt into the foundation. Now, not to be confused, there was an HDU-5, not to be confused with the HDU-E5, but an HDU-5, and now its equivalent replacement would be the HDU-E7. Okay. Now, I will say Simpson does make our lives kind of easy in that if you'll notice as I'm talking about these, the last number correlates to its actual tensile capacity. If I'm saying an HDU-E5, it has about a 5,000 pound capacity. You can look at the table to get the more exact. That gives you a very quick correlation of whether or not you're using an anchor that has equivalent capacity or capacity to resist the loading. And they do a good job with that with all of their hold downs. I'm actually really happy with that with the manufacturer. So HDU-5, again, 14 gauge construction, 14 structural screws into a double 2x member with a tensile capacity of 5,600 pounds. Its equivalent, same 14 gauge construction, actually uses slightly less screws, same double 2x, same concrete anchor. We're getting 7,000 pounds of tensile capacity out of that. So again, that's a little bit more than 20%, pretty significant increase. HDU-8, this is where things kind of change on us. The HDU-8, its replacement is the HDU-E9. Oddly enough, the HDU-E9 is actually a lower gauge material than, or thinner gauge material. If you remember gauges, as you get a higher number, the material's thinner. So an HDU-8 was a 10 gauge. The HDU-E9 is a 12 gauge. The HDU-E9 uses actually fewer structural screws. And if we compare apples to apples here, so installing both into a 4x4 wall element, the HDU-8 has a capacity of right at 7,000 pounds, and the HDU-E9 has a capacity of almost 8,500 pounds. So again, getting a good jump in our capacities. The HDU-11, let me hit on something here. So once we get outside of an HDU-5 or into an HDU-8, we get into a difficult area when we're engineering a home or we're specifying these. The reason being is with our builders, we always like to have a retrofit option. So where if they have a situation in the field where if they install the hold down, the anchor bolt in the foundation in the wrong location, or somehow it gets damaged, which does happen. Excavators, big piece of equipment, driving around a foundation, driving around a job site, happens pretty regularly. We like to have options, right? With the builder, something bad happens, we like to be able to go, okay, hey, you can chop that thing off, we can drill an epoxy in a new anchor bolt, and you can move forward with life. We lose that ability at about the HDU-8 or what is now the HDU-E9 capacity. We don't have enough capacity from our retrofit elements to work there. And so really now as we get in here and we get up in these sizes, we got to be way more precise. And just a side note here, this is something we started doing a few years ago on our plans, and it saved our builders a ton of hassle. Just me giving anybody that's an engineer or anybody that's a designer a gift of something that you guys can start doing to your plans that will save your builders hassle. And that was dimensioning out on the foundation plan where the anchor bolts go. Not all of the anchor bolts, like as your sill plate attachment, where your hold down anchor bolts go. Simpson provides us with a center line spacing of where that anchor bolt is supposed to be in the hold down. We know what the framing elements it is to attach to. We typically install hold downs adjacent an opening or a corner. So we know how many trimmers are going to be on that window or that door, and we know what a 3-stud corner looks like. We, as designers or as engineers, can properly estimate where exactly on that foundation plan that hold down anchor is going to go. And by adding that dimension, we make the concrete guys' lives so much easier. And I actually have statistics of this. Before we were doing this, we on average would have a anchor bolt retrofit every 20 to 25 homes, and where we're providing them a retrofit of a drill and epoxy, or in the case of a much higher capacity hold down, where I have to tell them, unfortunately, you got to demo out some of your foundation and replace it. We now have a misplaced anchor less than one every 200 homes. We did over 2,000 doors in 2025. I can tell you for a fact, we had less than 10 anchor bolt retrofit letters go out. It's astonishing the difference. And honestly, in the drafting time, once you calculate it and you build the offsets into an active block on that hold down call out to make the drafters' lives easier, it makes the foundation guys' lives so much easier. So just a little nugget of knowledge there to help you guys. Very, very important, very helpful. Okay, back into the comparison. So HDU-8 is now an HDU-E9. The HDU-E9, lower gauge material, fewer structural screws, slightly higher capacity. We go from a 7,000 to an 8,500. The HDU-11, now its equivalent is going to be an HDU-E13. Again, slightly thinner gauge material. It uses 7 less structural screws. If you ever saw the price of structural screws, SDS screws, it's a significant amount. Okay, but we go into a equivalence, right? So we'll go apples to apples here. So a 4x8 element in the wall, 4x8 member in the wall, HDU-11, 11,000 pounds, HDU-13 or HDU-E13, 13,000 pounds. Okay, again, almost a 20% increase in capacity. And then lastly, the HDU-E14 was a 7 gauge, so actually pretty stout material. I think that's almost 1/4 inch material. And again, into a 4x8 element, we had a capacity of 14,000 pounds. And into a 6x6 element, we had a capacity of about almost similar. So we had 14.4, we had 14.5. With the HDU-E17, we're a 10 gauge material, quite a bit thinner. We go from using 36 structural screws to 28, and into a 4x6 element, with the HDU-E17, we have 16,000 pounds capacity, and into a 6x6 element, we have almost 17,700 pounds capacity. So now key things to notice is that is the capacity of the hold down. We still have to design the anchor bolt. Now, the SB anchor bolt, which has been a commonly used anchor bolt for these HDU elements, that still exists. Those still exist. Just understand that they're using the more common A36 or grade 36 steel. It's a 1554 is the actual ASTM, but it's a grade 36, so 36,000 pounds per square inch tensile capacity steel. Now, in addition to those, Simpson has also come out with what they're calling a SABR. Is how I'm going to pronounce it. I'm going to pronounce it SABR, SABR. Okay, we're just going to call it the SABR anchor bolt. These new SABR anchor bolts are great because they bridge a gap for us in the what used to exist with the SSTBs, the SBs, and then going to what was called a PAB. And it's a great gap that they fill in that they're using a higher, they're almost identical to the SBs, but they're using a higher gauge steel, higher grade steel. So we go from a grade 36 to a grade 55, and we get away from the PABs. The PABs, or even the high strength PABs, were pain. They really are. They're a pain. I don't have a nice thing to say about them. And when you're trying to order them from Simpson. Now, there's an alternate to the PAB that we provide that is very easy to do, which is PAB basically stands for pre-assembled bolt. So us as engineers can provide an equivalency detail that says, hey, use these nuts, this washer, this grade all thread, boom. Now you've made an equivalent PAB to the Simpson one versus having to order them from Simpson. We still have to do all the supplemental engineering, show that it meets the requirements, but that's a great alternative. These SABR bolts, these SABR anchor bolts, bridge a gap that makes life so much easier. So the SABRs used in unison with the HDU-Es are going to get you that higher capacity. If you are going to use the HDU-Es with the old SB or SSTB bolts, your capacity is going to be limited by those anchor bolts. Okay. The hold down has much more capacity. Okay. Now, in terms of pricing, I'm going just by one vendor that we work with. There is a slight price increase, but again, they're phasing out the HDU series altogether. So unfortunately, this is a price increase that you're just going to have to take on. The HDU-E3 is about 10% more than its equivalent. The HDU-E5 is about 8%. The biggest difference is the HDU-E7 is almost 25% more than the HDU-5. But with that said, the HDU-E5 is less than the HDU-5, and they have almost equivalent tensile capacity. So if you use an HDU-E5 in lieu of an HDU-5 with an SB anchor bolt, it's the same capacity and it's equivalent capacity because your limiting factor is the anchor bolt, and you're actually less money than the HDU-5. And I would say on the whole, the HDU-5 is probably our most commonly specified anchor. The HDU-2 and the HDU-5 are probably most commonly specified anchors, with the only other one being the strap anchor at portal frames. And then the rest of them, the 9, the 13, and the 17 are all about 5% more in price. So again, HDU to HDU-E, not a huge difference. You have some savings in how many SDS screws you got to use. You've got more capacity available to you, especially used in conjunction with the SABR anchor bolts. I do love that they've really squeezed the tensile capacity out of these hold downs instead of just having them all in the horizontal plane, having a mix of horizontal and angular, so we can get some shear and tensile or withdrawal capacity. And as you're going on through your jobs, I recommend for any engineers or designers, you look at revising your schedules and then also look at these SABR anchor bolts. They're great. And last but not least, look at dimensioning this stuff on your plans. It really saves your contractors a ton of hassle, time, and money. All of us, engineers, designers, we're all in the service industry. Let's do our best to serve our builders. So that completes our first technical topics podcast. This one just kind of got dropped in my lap as I was working with our builders and we were finding out these things were getting phased out. I'm glad to be able to share this information with you guys. And I look forward to more of these technical topics. I love engineering. I love what I do. And anytime I get to talk with you guys about this, it's great stuff. So feel free to message us with any topics. If you enjoyed the show, please feel free to subscribe, share it with your friends. And if you provide something new and innovative to the market or interesting to the residential construction industry, do feel free to reach out to us. We'd love to have you on as a guest. And until next time, have a great day.